Hey everyone, and welcome to my session on building a next-level web app. My name is Eric Luce, and I'm so excited to dive into this topic with you. But first, let me back up and introduce myself. I'm a proud father of a 1.5-year-old son, plus a new baby we're expecting later this year. I'm a senior software engineer at Proofgeist. I live in Salina, Kansas, and I love board games and web technology. But before we can talk about building a web app, we should probably start by asking why web apps instead of some other technology that we may already be used to. To answer that question, we need to understand that the web is a fundamentally different place to build applications. For one, there's no software for the user to install or update. They always have the latest version with every click or refresh of their browser, the app that's already installed on every device they have. Web apps can run on any computer, even our phones. In fact, the very same web page can have code designed to make the screen be smaller or larger depending on whatever size that it's running on. And the web has technologies that can scale to support millions of users. So let me show you the web app that we'll be building in today's session. In this web app, I will need to authenticate myself using my email address, be able to view my profile, and make some changes to it. Let me show you how it'll work. I'll click Login, enter my email, and then I'll receive a verification email. When I click the link in my verification email, you can see that I'm automatically logged in and I can see my profile. If I make changes to my name and press enter, you'll see that on the left here, my profile was automatically updated. And likewise, in FileMaker, I can make this change, go back to my web app, and it automatically refreshes. Let me show you the tech stack behind this web app so that you can leverage it to build your own apps. For this web app, the base code is written in React and TypeScript, which includes the Next.js framework, the NextAuth framework for authentication, and a library called TRPC. We're hosting this web app on a platform called Vercel, and we're connecting to FileMaker using the FileMaker Data API. Of course, in this session, I'll be focusing mostly on the first part of this list, since there are other sessions where you can learn more about the Data API if you're interested. So let's start with Next.js and Vercel. Next.js is a framework that is all one language for both the server-side and client-side code. When you're writing web apps, web browsers can only run JavaScript. You don't really have a choice there. So Next.js allows you to write JavaScript for both your browser code and your server-side code, which helps you be a little bit more productive with less context switching between different languages. Next.js is also part of the React ecosystem, which is the most widely used JavaScript framework available. Because React has so many tools and components and templates that already exist, we don't have to reinvent the wheel when we're building our web apps. We can use what's already out there in the open source ecosystem. One other really cool feature that we like about Next.js is the built-in caching. Now, caching is one of the hardest problems in app development, but it's crucial to allow web apps to scale. Next.js makes this really, really easy, no matter which web host you're running on. But of course, we're running with Vercel because Vercel and Next.js were designed to work together. Of course, there are alternatives out there. Next.js is open source and it can run on platforms like Netlify, Cloudflare, but we chose Vercel because they were both designed by the same company, and so they work together by default out of the box. Let me jump into my sample code for just a second and give you a brief overview of my Next.js project. All of the code that you'll see me going over today are available at this GitHub repo shown on screen, or also linked in the session description. Now, this is not going to be a full tutorial of Next.js. For that, I recommend going through the Getting Started guide at nextjs.org, or find me at the Proofgeist booth here at AutoEnter. So instead of doing everything from scratch, I have a fully configured project here that I'll be walking you through the bits and pieces of in our short time together. To get started, let me open up my code editor and open up the terminal here, and then type yarn dev to start my dev server. So inside my source folder, I have a pages directory, and then index is my root page. Here I've got two components. I'm just going to command click on profile so we can see it. And you can see here that if I change the text here, this is because I'm not logged in, and I'll hit save. You'll see that if I refresh my page on the right, the text automatically updates. And now that we've got this live connection, live text, hit save, it auto updates. So this is my typical setup. I've got my code editor on the left, I've got a web browser on the right, and as I make changes, I see them automatically update in my browser. This is a basic Next.js app setup. Now let's talk about the next piece of our stack, NextAuth. Before we can really get into that, let's back up and talk about why do we need auth in the first place? Well, I would argue that every app needs authentication because without being able to identify a user, it's just a website. It's not a web app. So when we're talking about auth, we're just talking about the ability to identify a user, maybe display some data specific to that user, even if that's just stored within the browser, even if you don't have a backend database. Some web apps do this. And I also want to point out that what we're talking about here is authentication, not necessarily authorization. Authentication is figuring out who you are, not necessarily what you can do. Most apps will also need authorization, but we're focusing in this app just on being able to log in and identify who you are as a user. And the authorization piece, that's kind of a whole separate topic that we might dive into in a separate session. So let's look at Next.auth. Well, why do we use Next.auth? It's because it's built right for Next.js. It also supports many login providers: Google, Twitter, Facebook. There's just a whole list of them. And it even includes a magic email link. So if you don't want to integrate with any other service and you don't want to store passwords, you can just email them a verification code. The user clicks the link in their email and voila, you're logged into the app. Next.auth is also another open source framework, and what that means is that there's no other subscription fees. You don't have to pay for authentication providers. If you install it within your Next.js app, you own your data. You own the full control over your authentication stack, which is pretty great. And it also has FileMaker support with the adapter that we've built for Next.auth. There's a way that you can get right at your FileMaker users table while using Next.auth. Let me show you that right now. Once again, I don't have time for a full tutorial of Next.auth, so I do encourage you to check out their website for the full list of configuration options, but let me show you how we're using it in this project. This is the main configuration file for Next.auth that it shows you how to set up in their Getting Started guide. You can see that I'm importing a FileMaker adapter and an email provider. Next.auth exposes a wide range of authentication providers that you can use, like Google, Twitter, and email, and many more. And they also provide many adapters, which allow you to connect to your database to store your user data. So we want to use FileMaker for our database, and we want to log in via email, so that's what I'm using here. In this next little bit, I'm setting up the FileMaker adapter using my FileMaker username and password, which I have set up in environment variables. And then I'm configuring the Next.auth main object with my list of providers. You can have more than one. So here we've configured the email provider by passing it some SMTP credentials. The session strategy means that I want to store everything in a JSON web token, which is just the simplest and easiest way to get this set up and running. And then lastly, I have some callbacks, which allow me to change a little bit of what is in the JWT and my session token. That allows me to take data directly from FileMaker and store it into the JWT that is stored at the browser. On the FileMaker side, this is my FileMaker file that I'm connecting to in the back end. What we're looking at here is my list of users. New users will get created if they enter new emails when they log in. And I also have this table for verification tokens. When I go to log in and I enter my email address, you'll see that it creates a verification token record in FileMaker. When I get the link in my email pops through and I get to click the sign in like this. You'll see that the verification token gets checked. It looks up the token that was sent in my email, and then it gets deleted so that it cannot be used again. And once it's been verified, it logs me in, and now you can see that I'm logged into my app. If I were to click that same link again, you can see that instead I get an error because the token is missing from my table, or it would have expired if I waited too long to check it. All of this is provided for you by the Next.auth framework and the Next.auth adapter for FileMaker. All you need to do is install and configure Next.auth in your project and use a FileMaker add-on to add the necessary base tables to your existing FileMaker solution, or you can copy from our example file. This will give you the tables such as the user table and the verification token table, and from there you can do a one-to-one relationship between the new user table and your existing user table, or if you're starting a new project, you can simply add additional attributes, additional fields to that user table as needed. I'll show an example of what that looks like in a second, but first, let's take a look at the role that TypeScript plays in this web project. Now, if you've been around the web development world over the past few years, you've probably heard a lot about TypeScript and its benefits. And if you haven't, this might be a whole new concept for you. So let me give you just a quick overview of why I love it and why we choose to use it when building our web apps. Then hopefully during the demo, you can really see its benefits. TypeScript is a superset of JavaScript. So if you already know JavaScript, it's a small learning curve in order to get up to speed with TypeScript. When we've adopted it, and as I've seen other developers start to adopt it, I've seen most JavaScript developers take only a week or two before they're suddenly comfortable in the TypeScript land as well. And TypeScript focuses on making the development experience better for developers and our code safer while running in production. TypeScript allows me as a developer to be more productive, less guessing, less errors. TypeScript actually will detect errors for you in your code as you type. So if you're familiar with JavaScript, sometimes what happen is you'd write some code and you'd go to run it in a web browser and your page is white and you have to check your console and check your errors. In TypeScript, that all happens for you all while you're still in the code editor, still writing code. And it's a really, really neat experience. It feels like spell check, but not just for if your variable is wrong, although it does that too, but it actually will check for errors and it will warn you these edge cases. This all helps me be a better developer because it reminds me of these edge cases that back in JavaScript land I would tend to forget about. And another super important feature of TypeScript is its autocomplete and inline documentation. These are one of those features that as I was starting to get to know TypeScript, and then I would go back to an older project that might still be using JavaScript, I didn't realize how much I was missing these kinds of features. But the ability to have your code editor intelligently suggest to you, hey, this is the type of code that you might want to write, and it's going to work because it knows under the hood how the code all fits together. It knows what type of code is going to work, what kind of function calls, what your variables are, and whether those variables are objects or strings, or it knows all of those things. And so the modern code editor can actually suggest to you these autocompletes. And then for third-party libraries, you can have inline documentation such that if you even just hover over a function name, it can tell you what that function does, how the parameters should be passed to that function, and all sorts of great things. The other great thing about TypeScript is that you can adopt it incrementally with JavaScript. So if you already have a web project that is fully built out using JavaScript, you can add TypeScript to your project just for your new code, and you don't have to rewrite your whole app. This is a really great way to get exposed to TypeScript, and soon you'll want to rewrite your whole app in order to get these benefits of TypeScript. Now, these are just some of the many reasons that I love TypeScript in general. But let's talk about a few more specific features for how it helps us with web apps. We use a library called TRPC, which is a full-stack type-safe client. Let me break that down for a second. Full stack means that it works on the server side and the client side. It's actually going to connect those things for us really nicely. And type-safe means that it's going to keep our types all tied together in a well-trusted chain when we send data up to the server and back when we run it and we write code for our client. Now, the only way that TypeScript breaks down is if the actual code that you're running is not the correct type that you've told it that it is. Because as long as it matches those types, you can trust that your code editor will handle the rest of it, and your code editor will make sure that those types are used correctly. When you call APIs, though, and you get a response back from an API, you can't really know what that API response is, especially in production, unless you run validation against it. And that's one of the things that TRPC helps us do. Now, when we integrate TRPC with FileMaker, we get our FileMaker Data API client. Now, we've written this new Data API client for FileMaker, and it works specifically with TypeScript, and it even integrates with the FileMaker metadata objects in order to automatically generate code for you that TypeScript will use to give you autocomplete, the inline documentation like we talked about, and runtime validation. This will protect your web app in production in case someone removes a field from a layout that you were depending on or even just renames it. All of those types of things are what you get with this new package that we've put out as open source. And I can't wait to show it to you. Let's take a look in the demo of how all this works together. Let's look at how I'm using TRPC to display the data that's shown here and update my name when I fill out the form and submit it. TRPC allows you to define two types of server-side functions, mutations and queries. They both run on the server, but queries make it easy to fetch data and display it, whereas mutations make it easy to change that data. Now, within both of these functions, I'm using the FileMaker Data API client that I just talked about, but that may not be super clear based on my imports, so let me actually back up and show you how this works. When you install our Data API client, you'll get a new command line tool called CodeGen. When you run it for the first time, you'll probably get an error because it needs a configuration file. So I'll run it with the -- init flag to generate that file, and then command click on it here to open. There's multiple options you can specify in this file, but really the important ones are defining your layouts and a schema name. This is going to tell you what FileMaker layouts you want to connect to. In our case, it's called next.auth_user. And the schema name is just a user-friendly name that you're going to use within your web project. I'll call it user. I'll also add another config option called path, where I want to store these generated files. So I'll put that there. And now save the file. Let me run yarn CodeGen again. And you can see I get a message saying generated schemas. What this has done is if I go into FM schemas and user, this is TypeScript code that I'll be able to use throughout my project. In order to generate this, it used the same environment variables that I showed you earlier in order to connect to my FileMaker server, query the metadata endpoint of my layout, and then figure out which fields I would be returning whenever I hit the Data API for actual data. You don't really have to understand a lot about this code, but know that it's important for you to import in your other projects. So now, back in my user file, you can see that I'm importing the client from the user table, which is a layout-specific client that gives me both autocomplete and data validation. Just to show you how this works, which will also give you a sense of how TypeScript is helping me here, let me type client.get, and you can see that the autocomplete is suggesting to me what type of parameters I need to pass in. If I press Control Space, this brings up the IntelliSense, which shows me all of the available options. So get may not have been a great example because I'm doing this, but maybe let's do update, and I'll need to pass it a record ID of, let's say, 4, but of course we'll get that from later. And field data, these are all the fields that are on my layout that I might want to change. Another great example of this would be client.find, and I can see that I need a query parameter, and I can query by ID, and I can maybe get an ID, and I can say 1, 2, 3, 4, or whatever. I might post that in from another variable. Hopefully you can see this is the true magic of TypeScript. To be able to see my fields in line here and know that the query is going to work without having to reference documentation or without having to have my FileMaker file open, I can continue working with more certainty that the code I write is going to work when I run it in production. So now that we have that example, let's go back and look at these actual functions. This query function is where I'm fetching the data of my own user record. I'm passing in the session object so I can show that I'm logged in, and I can error out if they don't have a session. And here I'm doing this find one method, which is just a convenience method that will return a single object instead of an array when you're only expecting one result from a find query. And this will also throw an error if you get back more than one result. When I get field data, I can hover over this to see the name of my fields as well. And again, all of that supports autocomplete, so when I press just the period key, it automatically shows me the fields that I might expect. Now let's go back to FileMaker and see what happens if we add more fields to the layout. I'm going to click on this API layout because this is the actual layout that gets hit by the Data API, and I'm going to go into layout mode, and I'm going to create a new field called test, and just drag it onto my layout so you can see. Go back to browse mode, and I don't even have to have any data in here, but you can see if I go back to FileMaker, the new field comes through as we might expect when working with the Data API. However, if I were to go back into my autocomplete and I press period, I don't see that new field name in my list. So whenever you change FileMaker schema, you're going to need to update the generated types. And that's super easy by simply running the CodeGen command again. Now that I've done that, you'll see that immediately I type field data dot, and the test field shows up in my thing. And I can even hover over it and see that it is a string because it's a text field in FileMaker. So that's really, really great. I'm just going to console log this field to simulate the fact that we might actually be using this new field in production. But now, let me go back to FileMaker and remove that new field from the layout. I don't even have to delete it from my schema, but once you remove it from the layout, of course, it's not going to come back in the query anymore. This time, when I go to refresh, I get an error. And although this error isn't all that helpful, that's by design because you typically don't want to expose your errors to your end users. I could go back to my terminal in the server and I could see that there was a validation error where it expected a string. If I scroll up a little bit, it's a little easier to read. Okay, so it was expecting a string at this field, which is test, and it received undefined, which means the value didn't exist at all. Now, even if you didn't understand this error, what you might want to do is go back and rerun your code gen again. And now, immediately, we see that this is a red squiggly line, which tells us that the property field test is no longer on our types. So we get this error right away. Now that I can sync up my types with my actual code, I can very easily see all of the places throughout my entire project where this field may have been used, and I can either remove it or I can realize that I still need that field and add it back to the FileMaker layout. In my case, I'm going to remove it. And when I resave this and I hit OK to refresh, the error is gone and everything is golden once again. Finally, let's take a look at how TRPC uses this form to update our data in FileMaker. This mutation function takes an additional parameter of input in order to validate whatever data you want to pass to this update function. Under the hood, it uses Zod, the same validation library that we're using from the Data API client. So I'm importing this Z user object, which was generated from my types, and I'm applying this .partial method to it, which makes all of the properties optional, meaning I can only update whatever fields I pass in. I don't have to pass in all of the fields. Let's take a look at how that's used on our actual profile component. If I go to my profile component and scroll down, these are standard React conventions for how we change the field. So I'm controlling the input by reading the value of the name, and as I type, I will set my state to change the name. And then I've wrapped this whole element with a form with the onSubmit, where I'm going to set a form state, set the form loading, and then I'm going to try this handle submit function, which I'm getting from this TRPC use mutation hook. Let me close the sidebar here so we have a little bit more room. This use mutation hook is also fully typed. So this mutate async is the function I want to call, and within handle submit, if I remove this and open up my IntelliSense again, I get the same level of fields that I expected. So again, this is if I misspelled a field, it would tell me exactly what it would need to be. And since I already have a variable of name, it's just passing that in directly. And then it's calling a refresh so that after this is submitted, after the mutation runs, it automatically refreshes the data from above. Let me open FileMaker so you can see that live happening. And again, I'll change this, press enter to submit the form. It updates my data and refreshes the data all in one go. But again, this is all tied to our auto-generated types. If I were to go into my FileMaker file, the name field, and call it first name, for example, and change the name of the field, not only would this fail like before, and this is going to endlessly fail because we've got stuff, if I rerun my code gen, I'll be able to see that the handle submit function will also show me an error because it doesn't understand the name is no longer there. So there I get an error there, and I would have to say first name is name. And now I can refresh this again, hit OK. Now everything's working because the fields are expected, and as I change it, it's all going to work again as you would expect. All of this is possible with the help of TypeScript. And now that we have automatic type generation inferred directly from our FileMaker schema, we can build web apps that are connected to FileMaker faster and with more confidence than ever before. Thanks so much for watching. I hope you found some of the techniques I showed today inspiring for your next web app. Remember that all the code I showed today is available at the GitHub repo with the link shown on screen or in the session description below. I know I had to skip over a lot of stuff. If you have any questions, feel free to reach out to me. My contact info is on screen, or you can find me at the Proofgeist booth here at AutoEnter. We can't wait to see what you're building. See you next time.